Impulse is used when studying collisions in sports, as well as collisions with vehicles and passengers in vehicles. For this one, using this one to practice the vector nature, let's say we've got a baseball. Oops. It starts off going 20 meters per second south, which is pretty quick, but not crazy fast for a baseball. After interacting with the bat, it is then moving almost twice as fast, 35 meters per second, but the opposite direction. Because of vectors, there's a big difference between 20 south and 35 north. When we do the math, I'm going to call the 20 the negative vector and the 35 the positive vector. Often I like to call the bigger one positive. It doesn't matter which way you go, we'll agree on an answer when we get to the end. Impulse has two versions of its equation. Because this one we know a lot about mass and velocity, we're going to start with that. Impulse is equal to delta momentum. Mass isn't changing, so it's mv2 minus mv1. Plugging in numbers, the m was 0.14. The v2 is the second speed, so that's my positive 35. And then mv1, the 0.14. And my v1 was the negative for the opposite direction, 20. So you can see the double negative has the effect of increasing the overall quantity. So we end up with a momentum of 7.7. That's a positive value, so that means it's in the same direction as the 35, which was north. So what I'd like you to get into the habit with, you'll notice in the first two I didn't get too particular about it, but since this question gave us directions in letters, I want to make sure that when I get to the final answer, I give its final answer with a direction in letters. Then kind of like we did before, if we know the impulse, we can now use the second version of the equation to find something else. In this case, we can use it to find the average force. My 7.7 number is equal to force. The time I made up was 0.05. So the force is going to be 7.7 divided by 0.05. I get a value of 154. And again, because that's positive, that means it's north. So a little bit nitpicky, but since we got directions in the question, we have to have directions in our answer. Now, in these impulse questions so far, I've tried to be careful to say that when we found the force, it was the average force. 0.05 isn't a lot of time, so it's weird to think of it as an average, but probably what would happen is when the bat first came in contact with the ball, it would put a small force on the ball. Then maybe halfway through our 0.05 seconds, or like 0.025 seconds, we would be putting a huge force on the ball, way bigger than 154. And then the force would start to drop off so that by the time the ball was finished being in contact with the bat, so closer to the end of 0.05 seconds, the force would drop to below our 154 number. If we could think about graphing it, maybe that'll make more sense. If we graph the force versus time, if 154 was here, probably what would happen is we'd start off with a zero force on the ball, get to a really large force, then the force would drop back off to zero again, and that would take our 0.05 seconds. The average would be 154. It probably exerts a larger force than 154 for a chunk of time, but if we average out when it was under the 154 compared to when the force was bigger than 154, it would be equivalent to a force of 154 acting for the whole 0.05 seconds. So I'm always got to be a little bit careful and use the word average to describe the force. The force would probably peak much bigger than that and have times where it was lower than that as well.